Hello friends, Satyendra here, and in this video, let's design cam hammer using top-down assembly approach in Creo Parametric. So here I will design all the parts within the assembly environment, so I don't have any drawing for this. And once you complete this assembly, we'll play this mechanism just like this. So let's get started. But before I start, if you are first time on my channel and you have not subscribed this channel, then just take few moments to subscribe this channel. This will be a great help because 80% of my viewers are non-subscriber. So please subscribe this channel first. Thank you. Now to start this design, go for new, assembly, take the assembly name. So I'll take cam hammer, uncheck use default template, say OK, and select a proper assembly template. So I'll go with this and I'll say OK. So this is my assembly file. Now here I will create all the parts one by one. So I'll start with the frame, and to create the new part, go with this option, create. Here you have different items to create. You can create part, sub-assembly, skeleton model, bulk item and envelope. So for this video I will stick with the part. I'll take the part name. The part name will be frame. I'll just say OK. Now you need to select the part template. So this is my template. You can even browse a new template from here, but for me it is correct. I'll just say OK. So now you got a new part here. Now you need to assemble that part with this assembly constraint. So for this, you simply go to automatic and select default here. Say OK. A new part got assembled inside the assembly. This is your part datums and these are the assembly datums. Now just activate this part to create the part. Now for time being, I'll just activate name of the datums. Now here I will hide these assembly datums. Now to start the frame, first I will create a datum plane with reference of front datum plane. I'll just move it this side. This value I will take it as 25 or I will take it as 30. So let us take 30. Say OK. Now select this plane and then go for extrude, normal, switch off all the datums. Now hold shift and middle mouse button to drag it down. Now here I will create a center rectangle just like this, approximately. Now this height I will take it as 200 and this I will take 50. Or make it 180 and 50. Say OK. Thickness you take it as 10. Flip the direction and say OK. So I'm creating the base frame. Once again go to extrude, select this face, normal. Now create the rectangle just like this and like this, and one more rectangle somewhere here. Now this you take it as 5. This is also 5 and this is also 5. You can make equal to this to this. Now it has taken a mid constraint here. You just delete this. So I should have a dimension from here till here. This I will take it as 80. Okay. So all these dimensions I am taking approximately. So later on I can change this if needed. Now say OK. This you take it as 60 and say OK. Now the next feature onto this face. Here I will create a circle somewhere here. This I will take it as let's take 30, and this one also take 30. Say OK. Thickness again I will take 5 and say OK. Now the next feature, which is somewhere here, again you draw a circle approximately. Now this height I need a little bit down, so it is 130. Let's make it 120. And this one take it as 15. Say OK. Thickness 5. Say OK. So the frame is almost done. Now I'll just create 2 circular cut. Take the reference of this face. Now just draw a circle which is 5 mm diameter. Say OK. Flip the direction and then go for 2 selected and select till this face. Go for remove material. Say OK. OK. Now one more time cut onto this. Just draw a circle here. This is also dia 5. Say OK. Flip the direction, remove material and make it 2 next. Say OK. So the frame is done. One more thing we can do here. We can take this as 50, reduce little bit, and this item you can make it 20. Okay, and then I'll just cut this material, this take 10, and then say OK. Flip downwards and go for 2 selected and select this face, cut it like this. Okay, so this frame is almost done. Now go to assembly and activate this. Ctrl G to regenerate. So the first part is done. Now the second part is the hammer. So go to create part, take name as hammer. Say OK, select proper part template and say OK. Once again assemble it with the default and say OK. So part is created. Now you activate the second part and using this part reference design the whole part. So first I will switch on all the datums and I will hide these datums. Now I'll just use datum plane. So you see this front datum plane is exactly in the mid of this cylindrical feature. Now I'll select this front datum plane and I will go for revolve. normal. Place a datum center line somewhere here. Hide all the datums. Now I'll start this part with line. So I'll take this face reference. I'll go like this, then this, then I'll go up somewhere here, then I'll go like this, little up, come like this, then you simply go up like this, go like this and close this sketch. Okay, now the dimension. So this dimension I will take it as 40. Then I need this dimension. This I will take it as 30. Then this dimension, this is also 30. This die is 5. Then I need one dimension here. This feature will be little above this feature. So make it as 130. So this is above this feature. Okay. Now the total height from here till here, this you take it as 200. Then this feature, this take it as 5. And this value take it as 20. Just clean this. And the sketch is done. Now just say OK. Say OK. Then the next feature, which is somewhere here, normal. I'll go with center rectangle. I will just draw a center rectangle like this. This I will take it as 15, and this gap I will take it as 5. Say OK. Flip downwards, and then you can select to selected and select this face. Carefully, you see, it should not hit here. So I will just reduce the length little bit. So I will make it as 12.5. Okay. Okay, this is okay. I'll say okay. So now it is clear. Say okay. So this is done. So this feature is done. Now apply the round. Select this edge and this. Make it 2. Say OK. Select this edge and this edge. This you take it 2.5 and say OK. Then you go for round, select this edge, say OK. Again round, select this edge, make it 0.5. Hold the control key, select this edge, OK. And then one small round here and here. Say OK. Now the last round, somewhere here, make it 2.5 and say OK. And this part is also done. Now Control A to activate the assembly. Now the third part, which is the cam. So go to create part, take name as cam, say OK, select the part template and say OK. Assemble it, say OK. Now activate your third part and then design the cam. So for this, I'll go to extrude, I'll select this face and I will select a circle and I will draw a circle. So first circle I will draw like this, I'll say OK, flip the direction, take it as 20, say OK, again extrude, this time I select this face, draw a circle, draw a circle like this, taking this reference, say OK. Take this as 2.5 and say OK. So just say Control A to activate the assembly, and I think we need to move this feature little up. So I'll select this second part, activate it, double click here, and this I will make it 140. Control G to regenerate, Control A to activate. So this is how you work on top-down assembly approach. Sometime by seeing the reference, you need to move features up and down. Now once again activate this third part and then go for extrude, select this face, normal, go for circle, draw a circle, this I will take it as 20. Then I will draw a 3-point arc starting from here till here, just like this. This I will take it as 20. Then I will close this sketch using this reference. I'll just delete the segment. This segment I don't need, and this is also not needed. One segment here. Okay. Now if I make it 22.5, then what will happen? Okay. So it is coming here. So let it be 22. This is dia 20. This is radius 22. I'll say OK. This take 5 and say OK. Control Z, Control A. Now this surface should touch this surface. It should be tangent. So accordingly you need to modify this feature. So now see, you can modify this feature taking reference of this part, or you can modify this feature taking reference of this part. and that is why we follow top-down assembly approach while designing the part. So I'll just double click it. I will move it down, make 130 again, Control G. No, this is not correct. Move it 135, Control G. Yes, now this is tangent. Okay, now say Control A. I'll just activate this part. I will edit this feature. I will delete this reference and I will make it 17.5. Say OK and OK. Control A to activate the assembly. Yes. So now this is correct. Now you can even increase this value. This you can make 15. Control G. It is not hitting anywhere. Control A and Control G. Control D. So all three parts are done. Now save it. Now when you design a part inside the assembly using top-down assembly approach, all these parts are fixed to their location because we have assembled using default. So if you want to play this mechanism, then you need to reassemble it using dynamic constraint. So for that, I will simply create a new assembly file. Once again, I will go to assembly. I will take some name. I will select the proper assembly template. And here, I will call all the parts and assemble it using dynamic constraint. And this is the bottom-up assembly approach. And for this, you go to this option, assemble, and assemble the first part, which is frame. Select this and say open. Assemble it with the default because this is the first part. Say OK. Now just hide all these assembly datums before assembling the second part. Now once this is assembled, go for second part, which is the hammer. Select this part, open it. Now this part is moving part. It will slide up and down here. So if you see these constraints, these are the static constraint and these are the moving constraint. So here you have different type of constraint. So pin, slider and cylinder, these are the most useful constraint. So if your part is having rotary motion, then go with pin. If the part is having only sliding motion, then go with slider. If the part is having both the motion together, then go with cylinder. So this part is having only sliding motion, so go with slider. First thing you need to do is you need to align the axis. So you can switch on the axis from here and align this axis with this, or you can simply select this surface and align with this surface. Both are okay. Then the second constraint is rotation. For this you need to switch on the datum plane. And for this I'll just hide these assembly datums to avoid the confusion. It is already there. Now you just select this datum plane. This is hammer right. This assembly right, you just remove it and assemble with the first part, which is the frame. So frame right and hammer right. And then the third translation axis, select this face with this face. This you make it 0 and say OK. Switch off all the datums. So now if you go for drag component, you can easily drag this component. So here I will just create a snapshot. So this is the default position. Now when you apply the dynamic constraint, you get a box symbol here with a center dot. Now the third part, which is cam, so just double click it. Now this part, this is a rotary part, so I will go with pin constraint, and here also you need to align the axis. So you can align this face with this face, or you can align the center axis. Both are okay. Next is translation, so select this face with this face. You can apply the third constraint, or without that also your definition is completed, so you can just say OK. Now this cam part, I'll just open it. Here I will just apply a round feature. This I'll take it as 1, and one more round I will apply here. This I'll take it as 2, and I'll say OK, and I'll save it. Okay, so I got that. Now I'll just create a view. So I'll take name as A, and I will just rotate it with some angle. So let's make it minus 30 degree or minus 15 degree. Save it and say OK. So now you have another view A. So everything is done. Now I'll play the assembly mechanism. So for that, go to application and mechanism. Now to play the assembly mechanism, there are 3 things you need to keep in your mind. The first thing is dynamic constraint, which we have already done. The second thing is the connection, which you see here. There are different type of connections. And the third thing is the motor, which is this one, to run the mechanism. So here this connection, this part with this one is a cam connection. So go to cam. You have cam 1 and cam 2. So for cam 1 you can select surface or curves. So I'll select this surface, and if you select auto select, then by selecting this you can easily select other tangent surface. Just say OK. Then you go to cam 2. Here also you select the surface or curve. So here you don't go with auto select, you simply select this bottom surface and say OK. Then you say OK. So the connection is done. Now once connection is done, the third thing is the motor. So go to servo motor. Now this motor you need to apply to this symbol, because from this axis this cam will rotate. So just select this symbol. Once you select it, you can go to profile details, and here you have different ways to run the motor. So this time I will go with constant speed. So this one I will change it to angular velocity degree per second, and this I will take it as 90 degree per second. This is a constant speed, and I'll just say OK. So everything is done. Now just go for drag component and check it. Yes, it is working. Close it. Now to run this mechanism, go to mechanism analysis. Here start time is 0, end time I will take it as 20, frame rate let it be 10, snapshot, and just run it. Okay. Now just increase the frame rate to 50 and once again run it. Now this action is happening because this mechanism is having this gravity applied. So this will be applied by default. So you are getting the result. Say OK, and then you go inside this. If you want to convert this in a video format, from here also you can play it. You can go inside the capture and you can do some setting and say OK. You can select the frame rate and say OK, and it will start converting this motion into a video. And this complete this hammer assembly with mechanism. So that's it from this video. So this was cam hammer assembly using top-down assembly approach in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.